So basically, I study cosmology, which is the branch of physics that tries to understand the universe as a whole. So it's not devoted to individual objects such as galaxies or stars or planets, but tries to understand what the universe is made of, how it evolves, how it started. Essentially tries to answer really, really big questions about the universe. The field is very interesting now because we are flooded with data. There's much more data than workforce. So data in cosmology are basically different measurements of our universe. They can include the cosmic microwave background, which is relic radiation from when the universe is really, really young. They can include a distribution of galaxies with their position redshifts, which essentially encode the fluctuations in the universe, how the universe evolves. They can include spectra of very far away quasars from which we can extract information about the matter between us and quasars. They can include observations of supernovae, which tells us about the expansion of the universe. So they're a very varied field. It's a big variety of data here. You take your theories that have lots of predictions about our universe, and of course, you look at these predictions very carefully and you see if I'm going to slice my galaxies in particular ways, and if I'm going to analyze data in particular sense, then I'm going to learn this and this about the theories, right? So you want to extract the right properties from the data to isolate effects so you can learn about things you want to learn and leave away everything you don't want to learn about, right? Essentially, the data is a big mess in which the galaxies tell you at the same time about the evolution of the universe, the properties of galaxies, properties of dark matter, and so on. So what you try to do, you try to isolate various effects by looking at the data in different ways, like specializing for each individual aspect of a theory that you try to study. We've been focusing here on getting ready for the BOSS experiment. BOSS experiment is a long-term project. It's a collaboration of LBL and Princeton and a bunch of other institutions. Baryons, in a cosmological sense, are simply the ordinary matter in the universe. Things like protons, electrons, neutrons, stuff that makes ordinary atoms. In the earlier universe, before matter and light decouple, the baryons and photons form a plasma through which sound waves can propagate. These sound waves leave a very distinct imprint on statistical properties of matter that we observe, and we call them Baryon Acoustic Oscillations. And essentially, it's a project to measure the structure in the universe on the very, very large scales, which will allow us to understand dark energy better. The science is moving in the way of becoming more and more complicated, right? So I think cosmology now is at the level where particle physics was in the 60s. These days, things are becoming too complicated. So these days, we have big teams and increasingly large teams and increasingly large preparations. So doing science these days, at least in cosmology, is becoming a management issue as well as a scientific issue, right? So you can still do interesting things alone, but like the really, really big breakthroughs these days are going to come by concerted effort of essentially hundreds of people, right? And this is exactly where the particle physics moved on. Particle physics these days have collaborations which have a couple of thousands of people, like Large Hadron Collider, and we are moving in the same direction. What made me do physics? It's quite interesting. I didn't think I'm going to study physics when I was in high school. And I had a very exciting teacher who was a bit crazy, and just what I liked about him is that he openly admitted when he didn't know things. And it was very often he just said, I don't know these things, sorry kids. And most teachers just try to keep an authority, and this guy just let it go. So I thought, obviously, this subject must be hard if this teacher doesn't know everything, you know. So that's why I studied physics. But the cosmology, it was actually the end of undergrad. Essentially, I try to be on forefront on all kind of different data sets. So I do cosmic microwave background as well as supernovae as well as Lyman alpha. I try to do I try to combine all these data and make sense out of them. And I always try to find what is the most interesting to do at any given time. This is what keeps me going, right? Because every now and then I said, well, screw it. Why I'm doing this for this little money? You know, I could have gone to banking and I could have gone to management consultancy, And I could have driven, Mercedeses, and I would be a really boring person, But this time I go to parties and I say, I do cosmology, And people ask me questions, and it's good, right? So basically, money is not everything in this world.